Welcome back everyone. Today let's see the next 20 question and answers. Question number 91. For glass, the Young's modulus and Poisson's ratio have the values 7.2 into 10 to the power 10 Newton per meter squared and 0.25 respectively. Calculate the modulus of rigidity of glass. First, let's write the given data. Young's modulus E equal to 7.2 into 10 to the power 10 Newton per meter squared. Poisson's ratio nu equal to 0.25. We have to find the rigidity modulus G. The relation between Young's modulus, rigidity modulus and Poisson's ratio is E equal to 2G into 1 plus nu. On rewriting this equation for rigidity modulus, we get G equal to E divided by 2 into 1 plus nu. On substituting the values, we get 7.2 into 10 to the power 10 divided by 2 into 1 plus 0.25. We can write 0.25 as 1 divided by 4. Hence, the bracket inside the denominator becomes 5 divided by 4. The denominator of the denominator goes to the numerator. So, move the 4 to the numerator and multiply 2 into 5, which is equal to 10. Multiply 7.2 into 4, we get 28.8, and simplify the powers of 10, we get 10 to the power 9. Hence, the answer G equal to 28.8 into 10 to the power 9 Newton per meter squared. Hence, the answer is option A. Question number 92. A soap bubble of radius 0.01 meter is expanded to the radius 0.1 meter. Calculate the work done on it. Given the surface tension of a soap bubble equal to 26 into 10 to the power minus 3 Newton per meter. Let's write the given data. R1 equal to 0.01 meter and R2 equal to 0.1 meter. T equal to 26 into 10 to the power minus 3 Newton per meter. We have to find the work done W. For a soap bubble, the work done formula is equal to 2T into delta A. The surface area of the soap bubble is 4 pi r squared. Hence, the change in surface area delta A is equal to 4 pi into R2 squared minus R1 squared. Hence, the work done in expanding a soap bubble W equal to 8 pi T into R2 squared minus R1 squared. Substitute the values, and on simplifying the bracket term, we get 99 into 10 to the power minus 4. On multiplying the terms, we get W equal to 64,658.88 into 10 to the power minus 7, which is approximately equal to 6.47 into 10 to the power minus 3 joule. Hence, the answer is option B. Question number 93. In an experiment to obtain Lissajous figures, one tuning fork is of frequency 250 Hz and a circular figure occurs after every 5 seconds. What will be the frequency of the other tuning fork? Let's write the given data. F1 equal to 250 Hz and the time period to occur a circular figure is 5 seconds. That is T equal to 5 seconds. Hence, delta F equal to 1 divided by T, which is equal to 1 divided by 5. 1 divided by 5 is 0.2. We have to find the another frequency F2. Solution: F2 equal to F1 plus or minus delta F. On substituting the values, we get 250 plus or minus 0.2. Hence, the answer is F2 equal to 250.2 Hz or 249.8 Hz. Hence, the answer is option B. Question number 94. In streamline motion, the velocity of flow at any given point in the space of flow remains dash. The answer is option D, unchanged with time only. Question number 95. If 1 liter of glycerin gets reduced in volume by 0.21 centimeter cube under a pressure of 10 kg per centimeter squared, Calculate the bulk modulus of glycerin. First, let's write the given data. Volume V equal to 1 liter. The answer is given in terms of dynes per centimeter squared. Hence, we have to convert the volume in terms of centimeter cube. 1 liter equal to 10 to the power 3 centimeter cube. Delta V equal to 0.21 centimeter cube. Pressure P equal to 10 kilogram per centimeter squared. We have to find the bulk modulus K. The pressure term also written in terms of dynes per centimeter squared. We know 1 kilogram force per centimeter squared equal to 9.8 into 10 to the power 5 dynes per centimeter squared. Hence, pressure P equal to 10 into 9.8 into 10 to the power 5 dynes per centimeter squared, which is equal to 98 into 10 to the power 5 dynes per centimeter squared. The formula of bulk modulus K equal to P into V divided by delta V. Substitute the values, we get 98 into 10 to the power 5 into 10 to the power 3 divided by 21 into 10 to the power minus 2. For simplification, I have written that 0.21 as 21 into 10 to the power minus 2. On simplifying the power terms, we get 10 to the power 10, and on cancel the term 98 divided by 21, we get 4.67. Hence, the answer is K equal to 4.67 into 10 to the power 10 dynes per centimeter squared. All the given options are incorrect. Question number 96. When the number of turns in the primary and secondary coil is increased 3 times each, the natural inductance increased is dash. That is, they are asking the mutual inductance. Straight away we will see the solution. The formula for mutual inductance M equal to mu naught into mu R into N1 N2 into A divided by L. This formula I have seen it from 12th standard old physics book. If you learn the 12th standard books thoroughly, means you come to know the difference between the formula given in the old book and the new book. The given problem relates only the mutual inductance and the number of turns. Hence, we can write the formula as M is proportional to N1 and into N2. The number of turns in the primary and secondary coil is increased 3 times. Hence, the increased mutual inductance M dash is proportional to 3N1 into 3N2, which is equal to 9N1N2. Hence, the increase in the mutual inductance M dash equal to 9M. That is 9 times it gets increased. The answer is option B. Question number 97. Which of the following is dimension of self-inductance? In my YouTube channel, I have derived the dimensional formula for so many physical quantities. Let's check out it in the playlist Dimensional Formula. Aspirants, find the dimension of self-inductance of your own. In all the options, the letter I is given, but it should be A. At the end of this video, I will give the solution. The answer is A to the power minus 2 M L squared T to the power minus 2. Question number 98. An absolute electrometer is used to measure dash. The answer is option D, potential difference. Question number 99. In Thomson effect, if the Thomson coefficient of the metal expressed in joule per coulomb per degree Celsius is numerically equal to the EMF in volt, then the temperature difference between the 2 points is dash. The answer is option C, 1 degree Celsius. Question number 100. Integral over the closed surface B dot ds equal to 0 shows that the answer is option B. There is no isolated magnetic monopole. Question number 101. Bravier's lattice corresponds to the basic vector A equal to B equal to C and alpha equal to beta equal to gamma equal to 90 degree is dash. In my channel, I have uploaded various latest videos. Check them out. The answer is option A, cubic. Question number 102. Cell having more than one lattice point in an unit cell is known as dash. The answer is option C, non-primitive unit cell. Also, option B has the same meaning. Hence, both the option B and C are correct. Question number 103. The lattices reciprocal to each other is dash. The answer is option B, body-centered cubic and face-centered cubic. Question number 104. The mass of the unit cell with lattice constant A is dash. It is a simple problem. We know that density equal to mass by volume. Given that the lattice constant is A, hence the volume is A cube. Therefore, mass equal to density into volume, that is rho into A cube. The answer is option A, rho into A cube. Question number 105. The path difference between rays reflected from the adjacent planes which are d distance apart is dash, where theta is the angle of diffraction. The answer is option A, 2d sin theta. Question number 106. The difference between the crystalline and amorphous structure is. The answer is option C. Crystalline have regular internal atomic structure, but amorphous do not have regular internal atomic structure. Question number 107. What is the number of atoms per millimeter squared area in 100 plane which has FCC structure, given that the radius of the atom is 0.174 nanometer? Solution. Actually, they are asking the planar density. By deriving the effective number of atoms and area of plane, then substituting it in the planar density means it is a very long process. So, we have to learn the formula for 100 FCC plane is planar density P rho equal to 1 divided by 4 r squared. Given data r equal to 0.174 nanometer, which is 10 to the power minus 9 meter, but we have to convert it into millimeter. Then r is equal to 0.174 into 10 to the power minus 6 millimeter. Substitute it in the formula, we get 1 divided by 4 into 0.174 into 10 to the power minus 6 the whole square. Move the power term to the numerator, hence it becomes 10 to the power 12 divided by, multiply the term 4 into 0.174, we get 0.121104, which is approximately equal to 8.3. Hence the answer is 8.3 into 10 to the power 12 atoms per millimeter squared. The answer is option B. Question number 108. Which one is not correct for hexagonal crystal system? The answer is option D. Question number 109. The stacking sequence in a primitive cube structure is dash. The answer is option D, AAA. If you want to know which structure has the stacking sequence of option A and B, comment it in the text box. Question number 110. The bond due to electrostatic attraction between permanent dipoles is dash. The answer is option D, van der Waals bond. Which of the following is the dimension of self-inductance? The magnetic flux phi linked with the coil is proportional to the current I. that is phi is proportional to I or phi is equal to L into I. From that, L equal to phi divided by I. We know the formula magnetic flux phi equal to B dot A, and the force on the current carrying conductor placed in the magnetic field F equal to BIL. From that, B equal to F divided by I into L. The area can be written as length into breadth, that is L into X, by Newton's second law, F equal to MA. On substituting all the formulae, finally we get L equal to M into A into X divided by I squared. Write the SI unit of the physical quantities. We get kilogram meter per second squared into meter divided by ampere squared. This can be written as A to the power minus 2 kilogram m squared s to the power minus 2. Hence, its dimensional formula is A to the power minus 2 m L to the power 2 T to the power minus 2.